Hi everyone, welcome to section 2.1. Today we're going to be working on chapter 2. So we are working on chapter 2 material, which is exploring data with tables and graphs. Let's begin on section 2.1, where we talk about what does it mean to have a frequency distribution for organizing and summarizing data. So there exists frequency distributions that exist for organizing summarized data. And that's what we're going to look at on section 2.1. Now we're going to go into the specifics on histograms and graphs and Martin and BC. So in this chapter, we're only going to do 2.1, 2.2, and 2.3. What is the key concept of this section? So when working with large sets of data, there exists something called a frequency distribution or a frequency table that is helpful for organizing and summarizing data. So that is the first kind of the most important aspect of having distribution tables that will help us to organize and summarize data. A frequency distributions help us to, more than anything, understand the nature of the distribution of the data set. So how is our data being distributed? Let's first talk about the definition of a frequency distribution. A frequency distribution or a frequency table, what does it do? Well, it actually shows the data that are partitioned among several categories or classes. So they're separated by class by listing the categories along the number of frequency of data values in each of them. So for example, if I have a data, I'm able to separate by categories. And then this type is actually, it's defined as the classes when you have a frequency distribution. Within a frequency distribution, there exists a lower class limit, which is the smallest number that can belong to each of the different classes. So we have a lower class limit, an upper class limit, and class boundaries. An upper class limit is the largest numbers that can belong to each of the different classes, whereas a class boundary is the number used to separate the classes, but without the gaps created by class limits. Okay, so one thing is upper class, lower class, and boundaries. So the boundaries is used to separate the classes. So the boundaries are created to separate the classes without gaps or limits. There's also class midpoints, which are the values in the middle between the classes, is the middle number within the classes. Each midpoint can be found. How do we find a midpoint? You actually adding the lower to the upper and dividing it by 2. So it's taking the average. It's taking the average of the lower plus the upper divided by 2. Okay. Now there's a class width, which is the difference, it's the difference between two consecutive lower class limits in a frequency distribution. So this is a little bit different because it's actually the difference. So one is the sum between the lower and the upper divided by 2. The class width is the difference between two consecutive lower limits in a frequency distribution. So what we're going to do is we're going to be creating, or we're going to look at a procedure on how to construct a frequency distribution. That's what we're going to be doing in the following example. So what we're going to do is we need to first select the number of classes. This happens between 5 and 20. So anywhere between 5 classes to 20 classes. We wish to calculate the class width. Remember, how do I find the class width? Well, we notice the differences between the lower classes. And then we find the class width by looking at the maximum data minus the minimum data divided by the number of classes. And we round this to a convenient number. It's usually always best to round up. So these are the steps you want to take to construct a frequency distribution. The third one is that we're going to choose a value for the first lower class limit. So we need to choose a value for the first upper class limit. Okay. So we're going to choose the value for the first lower class limit by either the maximum value or a convenient value below the minimum. We're going to use the first lower class limit and class width to list the other class limits. We're going to list the lower class limits in a vertical column and then determine and enter the upper class limits. So we're going to start separating by classes. And then we're going to take each individual data and put a tally mark in the appropriate class. And then we're going to make a frequency. So let's say we have this example. Let's say using McDonald's lunch service times in the first table, the procedure shown on the next slide to construct the frequency distribution shown in this table, in the second table, uses 5 classes. So if we look at the time, it looks at the times in seconds it takes for the drive-through for McDonald's lunch services. So the first thing we want to do is look at the minimum value. Well, if we're looking at a minimum value, I'm looking at like a 91, and then I'm looking at a 90, and then I have an 83, and I think that's the smallest one. But we want to find something convenient to 83. So yes, we know that the minimum value is 83. This is the min value. But we want to be very smart in what number we want to pick. We want how many classes. It's asking us to use 5 different classes. So if we're looking at 5 different classes, we want to find, well, what's the class width? Well, remember, if they're telling us to use the number of classes over here, we're going to use this formula. So if we look at, let's say, the maximum data value, here in this example, I have a 2, we have a 308 to be a highest one. It looks like it. So if we look at 308 minus 83 divided by 5, we're going to look at a class width, so an approximate value, and we want to round up. So let's punch this in our calculator. We have 308 minus 83 was divided by 5. So we're going to take this number, 225. And then we're going to divide it by 5. It looks like 45. So that means that our class width is going to be of 45. So that means that we want to begin our lower class with something smaller that has a class width of 45, or even 50, because from here to here is 50, 50, 50, and 50. So 45 will round up. Will round to 50. So our class width will round up. So we will begin our lower class. So the lower class will begin with 45. Oh, sorry, with 75, because 75, you can say, well, we can pick 80. Yeah, but we want to be very selective on what number. Remember, my 2 frequency distributions can be different, actually. In this case, they started with 75, and then the other class limit would have to be 125. So 75 up to 124. So my lower class would be 75, 125, 225, 275. And then we start to count how many numbers are there between 75 and 124. Well, we're going to tally those. So anywhere between 75, how many do we have? How many tick marks? Between 75 and 124. Well, here's 1, 2, 3, 4, 5. Remember, up to 124. 1, 2, 3, 4, 5, 6. And then we have 7. And then we have 8, 9, 10. And then I'm missing one. Up to 124. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I should have another one that I don't see perhaps. So 107, that's 1 or anything between 75 and 124. Let's see, so this one's crossed off, this one's crossed off. 117, 101, 91, 113, 90. 127 is more, so not that one. 117, 119, 123, there's the other one. 123, oops. 123. And then 83. So there's my 11. And that's how I got my 11. Then I'm going to go into 125 and 174. How many of those do I have? I'm going to use a different color. I'm going to use blue. 125 all the way to 174. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then we will count in one of the numbers between 125 and 174. So then we're going to go ahead and continue. And then as we're crossing them out, all the way to 174, we see that there should be the 174, all of these. That's going to give me a tally of 24 of them. And then I'm going to do the same thing from 175 to 224. I should get 10 of those, 3 and 2. So then I see that what we're doing is a frequency distribution, where on this side, I have my number of classes. And these are my number of classes. I have 1 class, 2, 3, 4, and 5. That's how many classes I wanted. And I know that my class width was determined from the greatest number minus the smallest number divided by the number of classes. We got 45. And we rounded up to 50. Okay, because that was the most convenient number. Then we selected, of course, our class limits. Our class width was a 50. So we have our lower class permits to be 75, 125, 175, 225, and 275. And then we have our upper classes. The upper classes are 124. We have 124, 174, 224, 274, and 324. And those are my upper classes. So on the left side, this is my lower, and the ones on my right side, those are my upper class. So I have an upper class and a lower class, and the width between each of the lower classes is 50, which is the width of the class. Okay. So then what we did was we actually tallied. If we count 11, 24, 10, 3, and 2, we should get the total number of the data values we had initially. So 11, we plug it in our calculator, plus 24, plus 10, plus 3, plus 2. oops, plus 3 plus 2, we should get 50. So there's an amount of 50 data values. And that should correspond to the different times, right? So if we look at this, it tells me 50. So if I count, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 times 2 is 34. Times 3 is 51, but we subtract a 1. So it should be 50. So we add 50 of those. So it does match what we have. Okay. There's also something called a relative frequency distribution, which is each frequency is replaced by a relative or proportion. So the relative frequency is the frequency for the class divided by the sum of all frequencies. So the sum of all frequencies is the total number of values, which in this case was 50. So the percentage for each class, if we look at an example, is, for example, this is 11 out of 50 because our sum of our values is 50. And then we would multiply this by 100%. We would get a percentage. So this is a times right here. So times 100%, that would be a relative distribution for that one, for that class. 24 out of 50 times 100, that would be the percentage. Here would be 10 out of 50 times 100%. 3 out of 50 times 100%. And then 2 out of 50 times 100%. And that would be, this part would be my relative